Welcome back all. So this is going to be chapter 14 if I'm not mistaken, and here I will introduce you to the Windows API or Win API. I won't go through all the functions in Windows API, that would be stupid on my part, but I will show you how it is used, how you can access it, and from that point on, it's just a matter of you looking up various functions that are pretty much all documented and you can find them on the Windows website. Well, not MSDN, I believe you can find them there. But if you just type in WinAPI in your favorite search engine, you will be able to find what it is that you're looking for. Anyway, there's an entire list of functions and there's a description for each one of them, and on top of that you have examples. In any case, this chapter will encompass the basics of C++ program interaction with Windows API. API stands for, if you didn't know that, Application Programming Interface. Once again, Application Programming Interface, API. And you might notice that a lot of websites have their own APIs, a lot of other applications have their own APIs, and pretty much any serious application will have it where the user needs to, where the user is able to write some custom code for it or to write some sort of automated scripts, etc. Anyway, API, you know now what API stands for, and basically those are just the set of functions offered by an operating system, in this case Windows, to a program. So system-specific things, for example, GUI programs. Here we will talk about the basic types we meet in API, checking if function calls were successful, and getting additional information from the errors. Anyway, in Windows, functions are located in libraries. It is a good practice to write programs so that they are segmented into multiple units, as I have taught you in the previous chapters. The reason for this is simple. If we had an exe file of 10 megabytes, we would have to load all 10 megabytes into RAM, which is not really an effective way of doing it. However, if we had an exe file of 1 megabyte, which uses some libraries, then we only have to load that 1 megabyte into RAM, because chances are that libraries have already been loaded by other programs, so they can be utilized. This way, multiple programs can share one single library and save an enormous amount of resources on computers. You might think, oh, well, this is, unimportant. What if I have 16 gigs of RAM or 32 gigs of RAM, etc.? Well, one inefficient program can pretty much eat up all of it. If you write it in a stupid enough way, it can eat up all the 16 gigs and crash your computer. But imagine if you have semi-poorly written programs and you have maybe 20 of them running on your machine. Well, they're going to eat up a lot of resources, slow your machine down, and in all be very inefficient. There are, in general, two types of libraries. Keep this in mind, apart from this subject. You have static and dynamic. Static libraries are linked directly to one program, whereas dynamic libraries are available for multiple instances. In Windows, dynamic libraries have an extension .dll. So I'm pretty sure that you have all seen these. In fact, here, let me just go ahead and show them to you. Okay. And if we go, where on earth is it? Windows. I don't know, I always found the Windows a little bit confusing. System32. And if I scroll down, look at how many of them do you have. It's .dll, 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 etc. They go on and on and on. And sometimes you might actually find errors when you try to run a program. It's going to tell you missing that DLL or something like that. I would never recommend that you go out onto the net and download that particular dynamic library from some random website. Rather instead see what Windows has listed as an official solution, because if you're downloading it from a random website and if you're putting it in System32, well, that can be a problem, especially when you don't know what's in it. Anyway, uh, each library. Well, before that, just know that the DLL stands basically as a shortcut for Dynamic Linked Library. So DLL, Dynamic Linked Library, so that you know what those are. Each library is proprietary but has its own interface for using it. Library interface is described in header files. So I've already taught you what header files are. This is no different, really. So the registry library is called ADV API 32 DLL. Let me just write that out for you here. So ADV API 32.dll. A bit of a complicated name, but no big deal. It stands for Advanced API. That's it. It is an interface and its interface is described in the ADV API.h. So ADV API.h header. There is a special header that includes almost all other headers, and that would be basically windows.h. And this is something, if you intend to work with Windows API, that you will use quite frequently. In programs, it is almost always required to include only windows.h so that we can use everything we need from the Windows API. So the first line we have to write here in our code would be to actually include the windows.h. Let's go ahead and do that. Probably going to need IOStream as well, so I'll just leave it there. And this will be, it's going to go like this. So include, no different from the other ones, windows.h. There we go. So that's how you would include it. This way, we got prototypes of thousands of Windows functions, definitions of thousands of Windows constants, and hundreds of user-defined types as well, which are at our disposal when we actually include windows.h, which is fairly convenient and very practical. Now, we're going to go ahead and write a fairly simple program here. So we will use SW_show constant defined in windows.h. This is pretty much for demo purposes only. So let's go ahead and have a look. Cout, and I don't know. We've got SW_show constant. Okay, so let's go ahead and print it out as well. SW_show std : et al. Save it, Control S, build and run. There we go. So we've got SW_show constant, which is number 5. Almost all Win API functions return some value. Now, these values, in most cases, represent the status of function calls. For example, if function returns 0, that means that the call was successful. If the status was not 0, anything but 0, then we would have to check what was the reason for the unsuccessful call. To do that, we use the getLastError function, which describes what happened and caused the unsuccessful call. So this shall be explained further along the way, and we'll see how that actually works. For the time being, I'm just going to go ahead and bid you farewell, and then we'll move on into more complex things.